Hello everyone, today we will talk about the Java exception handling. In today's class, we will talk about what is the exceptions, what is the exception handling, what is the exception hierarchy, what is the difference between checked versus unchecked exception, what is the benefit of using try catch with finally block, and we will also talk about throw versus throws with some good examples, and we will also create one custom exceptions to relate the real world examples. And at last we will talk about some best practices. So as part of exception is kind of unexpected event that interrupt the normal flow of a Java program during its execution, which means if you are writing a Java program and somehow some unexpected event happen, then your program will break if you are not handling the exceptions, right? And it will not continue with their normal flow. So to overcome this kind of problem, we have to handle the exceptions, right? So what is the exception hierarchy? So in Java, everything is coming from the object class. So object is the parent of all Java classes, and after that we have a throwable class. Now throwable class have two child. One is like error, and second is your exceptions. Now exceptions also have two kind of exception. One is checked exceptions, and one is unchecked exceptions. So we will talk about this checked exception and unchecked exception in with the examples. So for now you can understand checked exception is known as a compile time exceptions. So as you write the code, so the Java compiler can able to recognize those kind of exception which coming under a category of checked exception. So if you write any class and if it extend the exception class, so it may become a checked exceptions. So instead of writing a custom class, Java also have other classes like IO exceptions, SQL exceptions, class not found exception, file not found exception, interrupted exceptions. All those classes extend the exceptions class. So which means any child of exception class also treat as a checked exception, and it comes under the compile time uh, exceptions, right? But in the other hand, if you talk about any exception, any class extend the runtime exception, then it will come under the category of runtime exception, or it is also called as the unchecked exception. So unchecked exception means if you these exception caught only the runtime environment. So Java compiler is not able to recognize those exceptions because those are the unchecked exceptions. So as example, null pointer, arithmetic exception, array index out of bound, all are comes under the unchecked exception. In the other hand, we also have the error, but these errors you can't handle it. So for example, like virtual machine error, JWT error, or out of memory error, stack or overflow errors. So these errors you can't handle. So these kind of error is like you have to look into those errors and provide the solutions once these errors are comes, or you can uh, put some kind of prevention sorry, to overcome of this kind of error. So if you talk about the out of memory error, so you have to think about carefully how much memory your program need to execute, right? So that's the way you can plan the memory required memory for your program, right? In other way, you may tweak your JVMs to overcome of such kind of problems before executing your program in some production environment or some higher environments, right? Now let's see what is checked exception and unchecked exception. We already talk about if any class extend the exception class, so it comes under the category of checked exception, and if any class comes under the runtime exceptions, then it comes under category of unchecked exception. For example, let's say we have a very basic example here. So if you see in this example, we are dividing two numbers, right? So as of now, we the integer a have value 10 and integer b have value 2, and once we divide the a divided by b, then we have the result. So let me run this program first. So if you run this program, so you can see we have started the calculation and the result is 5. So if 10 divided by 2, so result is 5, and program continues. So you can see this is the program which is continues after that, right? So now let me put 0 instead of 2. Now if you run this program, so here you can see we got the exceptions divide by 0, right? So it comes under the arithmetic exceptions, and you can see the error is like cannot divide by 0. So you may uh, you may know the math, right? This is a simple math. You can't divide anything with 0. The result should be infinite and you can't calculate those results. So that's how Java treat as a divide by 0 error or divide by 0 exceptions, right? And in this case, we have handled the exceptions properly. So you can see after exception coming at line number 12, exception comes and we handle it here, and then we also able to continue our program. Here is you can see one of the thing noticeable. You are not getting the line number 14 output, right? You can see the starting calculation is coming, then directly at line number 12 exception comes. Exception, as soon as the exception comes, the program jump to the catch block, right? And you will get the uh, you will get the error whatever you have handled it. So you have handled it and put a particular statement. So you can see this output you are getting here, right? The cannot divide by 0. And as soon as you handle it, then your program is also continue. So whatever the line you will return, whatever the logic you will return after the catch block, that will execute. So that's how this provide the robustness in your program. So robustness means if something happens, something unexpected happened within the program, and if you are able to handle it, then the program will continue with further flows, right? So let's say if I just comment it out for now. So now you can see what will happen. Now here you can see we here we are not handling any exceptions. Now the starting calculation will execute, and you are seeing this is the output of that particular line. Now we will got the exception at line number 12, and as soon as we will got the exception, we got the exception from the JVM. And here you can see if you are not handling it, so Java program will throw that exception, and that exception catch by the JVM, or you can say the main method, right? So JVM will stop the execution, because you can see there is no line printed as a program continues, right? As soon as the exception comes, your program break down. So you can see your program has stopped here, and you are not able to run further executions, right? So that's how the exception handling is very important. You have to handle it in a proper way, so your program may continue further execution even if some unexpected event happens, right? And here you can see, if you talk about the arithmetic exception, this is a runtime exception. So because it is extending the runtime exception class. So that's how you can say arithmetic exception is runtime exception or unchecked exceptions. Okay, so in the other way, we also have like input output exceptions, right? So if you talk about the input output exception, it extend the exceptions. So this is a checked exception. We will talk about this checked exceptions in that example, but for now you can see the difference between unchecked and checked exceptions. So if you talk about the arithmetic exception, it extends the runtime exception. That's how it is called as the unchecked exception or compile time runtime exceptions. And once you talk about the IO exceptions, so IO exception extend the exception. So that's how it is your compile time exceptions. Okay, so we have talked about checked versus unchecked exceptions, and we uh, also see the example, one of the example, and the importance of exception handling, right? So as we demonstrate why exception handling is very important. So if you don't provide any exception handling, your program will stop and you may not execute further logic within your program. So and you to execute your program properly, or generate the output continue, you have to handle those exceptions. So exception handling provide the multiple benefits. Some of the benefit I have listed here. So one of the benefits like prevent abnormal termination. So help you prevent the application from crashing or terminating unexpectedly, right? It will improve the reliability, ensure that the application can handle unexpected situations and continue its normal flow. So as we have seen in the program, as soon as we have handled the exceptions, our program will continue and we are able to execute the line written after the catch block. So that's how it will provide the reliability within the program. It will also increase the user experience, right? If somebody is using your program uh, in production or in live or live world, right? So let's say if you have written, you have you have written one kind of user input program, right, where you want to capture the user data, right? And user data, let's say you are capturing the data, user data in form of name, age, their city, their email address and mobile number, right? So basically then once the user is input has input their age, most of the time age is like a number, right? So you may have the age as a number in your program, but somehow if a particular person written uh, 24, not 24, it has written like in English word 24, right? So in that case you are not able to store that English word 24 to number 24. So that's how you will get the exceptions. So if you are not able to handle it, so your program will stop, and further you are not able to provide, you are not able to get another further information from the user. So what is the benefit of using exception here? As soon as you handle that exception, you can generate the message to the user and say that we are expecting age in the form of number, not the form of string or any word, right? So that's how it will increase the user experience, and your program may continue and make create a reliable solutions, right? In the same way, easier debugging and maintenance. So what is the meaning of easier debugging and maintenance? Once you have the exception and you are handling those exception in a proper way, so you can put log in your programs. You can log those exceptions error within the program. So later on, those logging will help you to debugging those issues within your program, right? Because in once you talk about the production kind of environment, so mostly people don't have the access on the on the programs, right? On to debug, you can't debug live programs, right? So the logging will help you to find out the issues, right, in a proper way. So how it will happen? As soon as you provide the proper logging, those logging will capture and put some kind of log stash kind of tooling, and those tooling may push that data on your Kibana or Splunk search, from where you will get the idea is what is happening in the system and what is the error you are getting. So this is like also a use case of providing observability within the system. And once we talk about the clean code, yeah, clean code is once you have the exception handling proper way, then you can promote the separation of normal logic and error handling, making code cleaner and easier to maintain, right? Now we have seen that what is the use of try and catch, means that block is help us to uh, handle the exceptions, and the further flow will continue. But there is another use of using try catch and finally. So what is the use of try catch and finally? Try block is contains the code that might throw exceptions. So try block is always used for where you may have the exceptions. So those code block you can write on the try block, and catch block is catches the exception, handle it, log it, all those things can be done in the catch block. And finally block is there it basically it's used for the cleanup task. So what is the cleanup task? So let's say if you are opening a database connection, and after opening a database connection you may get some exceptions. So the you if you get some exception, then your program will stop at their particular point, right? So you are not able to do that further action from the database, and that time your responsibility is to close the connection, because you don't want to make a connection indefinite time. You don't want to make that connection open for unlimited time, right? So it will actually database connection, file connection treated as a resource in the network, right? So if you are not using it, you have to close it, so further application can reuse it. So that's how we this is our responsibility. If we are using any resource within the system like database connection, file connection, so we have to close it after completing our work. And after completing our work may have two kind of things, means our work will complete successfully, or our work may interrupt via having an exception within the program. So in both way, this is the responsibility of our program to close the exceptions, right? To close those connections. So let's see how we will do that. So here I've created one example. So in this example, what you can see, we are trying to open a file, right? So you can see we have a folder here. In this folder we have a file, text file. This text file have some data like customer ID, name, email, account types, and balance, and we want to read this file within a program. So for this file read, Java has provided a file input like buffer reader. So this buffer reader will it comes from the Java in IO package, Java input output package, right? So this buffer reader is used to create a connections, input output connection to read that file from a particular path. So for simplicity, I have taken this file in my particular resource folder. But if you talk about the real time example, so this file may exist on some cloud location like S3 bucket somewhere else, or maybe some intranet from where you have to make those network connection first, and then get the path of that file and then start reading. So for simplicity, let's run this program and see what is the output here. So if you run this program, you can see we are able to read the file, and whatever the data is there, we are able to read it, right? And you can see before reading the file, we are printing some kind of a statement. So this statement says that we are opening the file, so we are making a connection to that particular path. And after once the so it is like saying that opening a file, and once we are hitting the buffer reader, and this buffer reader is expecting a file reader object, and file reader object we have to provide that path. So once this reader will connect with that path, then we will start the reading of that file. And once we start the reading of file, then we are putting one of the while loop, and this reader will read the line by line that file and start printing each of the line present in that particular file. And once that once that reading is complete, then it will close the connections, right? So here you can see after reading the file, you will get the closing file kind of output. So here you can say we are fine, and finally we will get the output, and finally we will we are closing that particular connection, right? So this is very important, because you can treat this is like kind of resource we are using to run that file, right? So let's say if your file is in S3 bucket, so you have to make that network connection to that particular bucket address, and then start reading it. So, and after your work completion, this is your responsibility to close that connection. So further programs may reuse the same connection, because resource has the limited numbers within the programs, right, within the network. So you can't open that resource in unlimited time. So this is our responsibility. After completing our work, we have to close those resources. Now what is the benefit of finally block? So it doesn't matter exception will happen, not happen, finally will execute always, right? So here in this program, you can see there is no output we are seeing as a error while reading file, right? So if exception will happen, then also the finally will block will execute. Even if the exception is not happen, then finally will block also execute. So finally block will give us the guarantee that we are able to close the connection. It doesn't matter our task is completed or not completed, right? So in the same way, let's say now let me do one kind of tweak here. So let me incorrect that path. So I just remove the s from there. Now the path is incorrect. Now let's run this program. So once we run this program, now you can see there is no output coming from the file, because we are not able to reach that file. Why? Because the path is incorrect, right? So we have the output as like opening file. Now once we try to read it, we are getting the exceptions. As soon as we get the exceptions, we have message like error while reading the file. Now the exception will come, and after exception we will move to finally block, and it's saying that closing the file. Why it is not showing file closed successfully? Because we didn't open the connection yet. We are getting the exception in this particular line number 15, right? So this reader is never executed, so there is no reader object. So if there is no reader object, so there is no connection open. So if there is no connection open, so there is no way to close it, right? So that's how we have given um, given a null check here. So this is very important, because let's say in this particular time the reader object is null, right? So if reader object is null, so if you don't put this particular check, and then and without that check, if you try to close that reader object dot close, then you will get the null pointer exception. Why it is null pointer exception? Let me debug it, then you can see very well. So let's say if we debug this application. So here you can see the reader is null, right? Why reader is null? Because we are getting the exception under after this line. Okay, so let me do one more thing. Okay, so let me run again. So let's debug it again. Now you can see we are in this line number 13. Go to next. Now you can see the output is opening file, right? Now if you go to next, so it will try to open a connection and try to read that file from this path. So the path is resource data.txt, but the correct part is resources data.txt, right? So s is missing here. So it will try to reach that path and try to read that file. So as soon as you come here, you are in the exceptions, right? Because the reader object is null, because due to this incorrect path, right? So reader is null, and we got the exception. What exception? Input output exception, right? We got that exception, and in exception we are printing error while reading this file, right? Now after exception it will go to finally block, and it's saying closing the file. Now it is a very important check, right? If the reader is null, so you don't need to do anything, because the connection will never happen. There is the connection never open it, right? Because the reader is all null here, so the connection is never open. We are not using any resource here. So if there is no resource, no object creation, so it is there is no sense to close that connection, right? Because that connection is never open. So this check will give the guarantee that we don't need to do any kind of uh, connection closer, right? So I think you may got that point, right? If you don't put this particular check, so here this will come as a null dot close, and null dot close will give you another exception like null pointer exception, right? So you don't want to have another exception within your program. So that's how we have to put that particular check, right? So if you go next, so it will complete the program execution. So I hope you will understand the use of try, catch, and finally. In the same way, if you don't want to write this much code, so Java provided another feature of this try block. So we have try with resources. So this is this particular code doing the same thing, but only with less number of lines, right? So if there is a resource based connection you are using within your program, like a file reader or database connection, so you may use this particular functionality of try with resources. In this particular uh, try block, you may declare your resources, right? So it will take care of all those finally kind of activity here. So you don't need to write finally here. So all the if you are putting any resources within a try block, so try block will override this close method, and it will handle all kind of connection closing, right? In the same, if you run this program, so you will get the same output. Okay, so here you can see reading file started, then we have started the file reader, and we are able to read line by line that file. And once the file is completed, then we are closing the collection connection, and after that we are executing the further flow. Okay, so we have seen the use of try, catch, and finally block, where try block contains the code that might throw an exception, and if exception occur, the remaining code in the try block will escape, right? And in the catch block, catches and handle the exception thrown in the within the try block, and have multiple catches block we can also use to with different exceptions, right? Once we talk about the finally block, so finally block is help us to close all kind of open connection. It will use for resource utilizations, so there are benefit of using finally block. Now we will talk about throw versus throws. So throw is used to explicitly throw an exception, while throws used to method signature to declare exception. So it is very important difference. So why we need a throw, right? And why we need a throws? So here you can see, if you have to declare an exception within the method level, method signature, then you can use a throws keyword. And that if that method will is if that method is calling somewhere within some another method, then that declaration will help you to catch that exception within that method, right? So here you can see the read file is declaring that it is a like a resource based calling, because the read file need to make a connection a particular path to read a particular file. So if there is some issue within that uh, within that path, or that file is not exist, or maybe the some typo issues, the file name is incorrect, whatever you are passing here, so in all those scenario it will throw an exceptions, and you will put that exceptions in the method declaration, and whenever you are calling from there, you are able to catch it. In the same way, if you want to throw exception within a particular line, so you don't want to declare your exception within a method level, but you want to throw exception within a particular line, then you can use a throw keyword. So here you can see we are not declaring any exception here, we are throwing within a particular line. So here you can see we are throwing a throw new illegal argument exceptions, right? So this is the difference between throw versus throws, and it help us to follow a best practice in exception. That the best practice is called as throw early, catch later. So if you want to propagate the exceptions layer, so we have to follow this rule: throw early, catch later. Throw early means as soon as you will get the exception, you don't need to catch there, you have to catch from where you are calling, right? So it will follow the rule like throw early, catch later, right? So if you see the particular example here, throw versus throws, so here you can see we have written a particular method withdraw. Basically it is withdraw money, and we are throwing here as a illegal argument exceptions, right? And this illegal argument exception give me the declaration on that particular method, what we have to throw here, right? So let's say if we are trying to withdraw a particular amount, and if that amount is less than your existing balance, then if amount is less than your existing balance, then you are able to withdraw that amount. So let's say if your balance is 5,000 and you're trying to withdraw 3,000, so that's okay, that is a normal process. So 3,000 will withdraw and remaining 2,000 will exist in the as a balance. Even if your balance is 5,000 and you want to withdraw 5,000, then it's also still it is okay, right? Because you can withdraw all your balance and then the balance becomes zero. But if you have a balance like 5,000, if you want to withdraw as a 7,000, then this would not be case, right? You can't withdraw money more than your balance, right? So in the same way, let's say if I'm just running this particular example, here you can see I'm withdrawing 5,000 and my balance is 5,000. So if I'm running this particular program, so you can see I'm able to do the withdraw, right? But as soon as I increase the amount with my compared to my balance, then it will throw an exception, right? So here it is saying that transaction failed, insufficient balance. Why it is insufficient balance? Because I am trying to withdraw more than my existing balance, right? So here what is the use of throws help me to declare that exception. So if I'm hitting that throws illegal argument exception here, so I don't need to uh, catch that exceptions here, right? And I am catching in my calling method. So this is like a simple example, but in like complex examples, you may think about, we have lots of classes, like classes, and one class method call another class method, another class methods call another class method. So that uh, method chaining is involved within that particular program. So we don't want to catch those exception as soon as it occurs, because in that way we are not able to capture those chaining, right? So in that way we have to follow the rule, throw early, catch later. So here you can see, as soon as the exception occurs, we are throwing it. We are not putting any handling here, right? So in that case, we are throwing it as soon as the exception occur, and we are handling whenever we are calling, wherever we are calling, right? We are calling from this main method, and here we are handling. So this is the rule of your throw early, catch later, right? Now, if you talk about the custom exceptions, so in Java, we can also create our custom exceptions. So there are two ways to create our custom exception. One way is like using exception class. So you can extend your custom class with your exception class. Then your class will also become a exception, and it is known as a checked exception. Why it is a checked exception? Because exception is also a checked exception class. And another way is like you can extend your custom class with runtime exception, and then it will become your unchecked exception, because runtime exception is unchecked exceptions. Okay, now let's create one kind of real-time example. So here you can see we have order service, we have order application, and we have invalid order exceptions. So invalid order exception is my custom exception class, and is extend runtime exception. So runtime exception means my invalid order exception is runtime exception or unchecked exceptions. Why it is unchecked exceptions? So let's see the flow. So in order service, what we are doing? We are doing a place order activity, right? We are placing an order based on the quantity. So what it's saying, if quantity is less than 0, so it is a invalid order exception, because you there is no such case where you want to make a order with 0 quantity, right? If you are making order, you have to order something, right? It may at least quantity should be 1 or more than 1, right? But 0 quantity order is like invalid order. So in that case, we have put a check here. If quantity is less than 0 or equal to 0, so it comes under a category of invalid order exceptions. And if not, then we will place your order. Okay, so in the same way, you can have this is like a lower limit check. You may put another upper limit check. Let's say if we, as a particular order, how many quantity you can order, right? So you can't order 1 lakh orders in a particular order, right? So you can put all those checks here, right? But for a simplicity, we are just checking if a quantity is less than 0 or equal to 0. It comes under the invalid order exceptions. And what is the order application is doing here? Order application is doing here, creating order service object, and it place order. So right now, let me add the order quantity is more than 0. Now see what is happening. Let's run this program, and now you can see order placed successfully for quantity 1, because it passes that check, right? Sorry. Now make it 0. So now I'm trying to place an order with 0 quantity, right? So now you can see order failed. Order quantity must be greater than 0. Why it is greater than 0? So you can see in order service, we are throwing a particular invalid order exceptions, and invalid order exceptions we are catching here, right? This invalid order exception is catching here. So order dot place order is throwing an exception, right? And we are catching in the calling application, right? So it is like throw early, catch later, right? From the calling method we are catching it, and this is my custom exceptions. So this actually custom exception help us to identify what kind of issue is happening. So in real time we have to create multiple custom exceptions. Let's say if you talk about the same way invalid order, or maybe the address you are providing is not deliverable, right? Some sorry. So if you talk about some kind of remote locations where delivery partner or our delivery partner is not delivering any product, so you may have another type of exception, like we can't deliver in this particular pin code, right? We you must have seen such kind of issues on online e-commerce site, right? Somewhere if you are putting some kind of pin code, and you may have kind of messages like it is this pin code is not serviceable, right? So those kind of custom exception you can create by your own. And the benefit of using those custom exception, you may provide a meaningful messages, right? So these are the meaningful messages for the end user. So here you can see order quantity must have greater than 0, so user can easily understand they can't make an order with quantity 0, right? Okay, so this is the type of runtime exception. So 99% or maybe most of the cases we are creating custom exception with runtime exceptions. And runtime exceptions is like there is no compilation error, right? Once you run this program, then based on your logic, the program will decide the exception will occur or not occur. And if occur, then what is the handling you will provide, based on that your program will run. Now let's say if I want to change this custom exceptions to exception, right? So let's say I just check, I am just replacing with runtime exception to exception. Now you will see we have an error, right, in order service, in order application both. Why? Because this is a compile time exception. This is a compile time exception, so we are getting the error in compile time. So what it is showing here? It is saying if you are using any compile time exception or checked exception, you have to throw those exceptions, right? So you have to make that declaration that uh, this particular order place order method is handling or throwing invalid order exception. And if the invalid order exception is checked exception, then you have to declare it that this is like this method is throwing a checked exceptions, right? So once you throwing it, then all error will gone, and your program will work as expected, right? So if you run this program again, then you can see the same error you are getting, because we are placing the order with 0 quantity. So let's say if we increase the order quantity, then we are able to place the order. So I hope you are able to uh, get the idea what is the difference between runtime and compile time exceptions, and what is the benefit of using runtime exception and custom exception within the program, right? These are the best practices for writing exception handling within your program. So be specific, not generic. So this is the very first rule. So let's say if you are doing multiple thing, let's say you are opening a file, reading the file, and after that reading file you are creating a database connection and storing that file data, some of the data from that file to your databases. Then you are using two kind of connections, right? A file input output connection, and second is your DB connection. So in the same way you may have two kind of exceptions occurred within the system. So one is like your input output exception, and second is like your database connection. So you may handle both connections separately. So why separately? In that, if you are handling both connections separately, so you may customize your message to your end user, means what is happening within the system, so user may have some idea what is happening, right? And at the very last you can put your default behavior. So the order should be like file not found exception, then database exception, then exceptions. So if something something some other logic is not working, maybe some transformation, some other issues, some bad logic written in the code, then your code should also able to handle those uh, exceptions as well. And the second best practice is like provide a meaningful message. So meaningful message will give your customer or your end user a better idea. So as we talk about the user form, you want to take a user data via user form within a a web API, a web app. You may assume like or maybe a mobile app. And once a user want to add their details, then let's say if you want to take a age as an input, right, or name as an input. So somebody is writing a 24, not a number 24 in string, they're writing as a TWENTY20 and FOUR4 like 24 as a string. Then if you are storing those thing as a number, so you may have the number format exceptions. In that case, instead of saying a number format exception, you may write a message like you are expecting a age in form of number, not form of string. Because most of the time most of the user may not know about the what is the number format exception, what is the meaning of that. So in that case, you can write some meaningful messages to your end user, and they may have some idea means what to do. So they may replace the string value to number value, right? And the other best practice is like don't ignore the exceptions, because if you ignore the exception, your program will break and stop execution. And other best practice is like log the exception properly. So if you log the exception properly, your program will run on the higher environment. You may create an alert on top of those errors, and you have a very good observability within your program. Use try with resources. As we already talk about, resources are very like cost cost related issues, right? Every connection has a cost in your network, right? So you don't want to open your connection if you got any exceptions. So this is your responsibility. If you're using a resource within the system, and if you are opening a connection, you have to close it. It doesn't matter there is exception comes or you are able to complete your program. Don't overuse exceptions. So don't overuse exception means exception are for exceptional situation, not for normal control flow. So sometime your if else block may help you to decide the flow. So it is not like that every time you have to put exceptions. So overuse exception is also a bad design. And other thing, rethrow when necessary. You can rethrow your exception when it is necessary. You don't need to rethrow again and again. So rethrow means you are after catching your exception, you want to throw an exception again. So that is very limited cases or very specific cases where you have to rethrow your exception. Otherwise you should ignore it. Create custom exception. Custom exception is very useful. It will help you to write the right decision. It will help you to type of deciding the type of exceptions coming within the system. So it will create it is like a best practice for your clean code. And the other thing is like keep clean up in finally try with resources. It is the same with it is similar like try catch finally, as we discussed in resource utilization. And then document the exception. So exception documentation is very crucial. So let's say if you are writing a code, you have to use a Java documentation to write to provide a proper documentation. So this is very useful when anybody is using your APIs. Like, so if you talk about your B2B APIs used by other vendors, right? If you talk about the Amazon APIs or some, let's say if you want to create S3 buckets, right? So they have documented all those issues within those their SDKs, their libraries. So if you are serving any your project as a library, then you must have to document all those exceptions, error codes, all kind of signatures. So this is very important. So I think you may have a very good idea about the best practices about exception handling. Now, thank you. In the next lecture, we will talk about the Java data structure. Thank you.